Okay, today we're talking about Chapter 7, Section 2, the quadratic formula. So, in the last section, we did the square root method, and there's nothing wrong with the square root method. It's just it takes some time, right? And I guarantee you probably didn't like it. And well, I mean, you're probably not gonna like this either, but it's a lot easier. Um, we're talking about the quadratic formula. I'm going to go ahead and snip the derivation of the quadratic formula. It's not very hard to follow. In fact, matter of fact, I'm going to give some high points of it real quickly because I know when I was taking algebra for the first time, I was thinking, dude, what maniac, what just insane person sat around, put uh, square roots and pluses and minuses in just the right places to come up with the quadratic formula. Well, the truth is, the reason why it's called a quadratic formula and not why it is called, Euler's formula or somebody famous's name is attached to it is because it's very easy to derive. And by doing so, all you have to do is complete the square. Right? So if you recall, I said that you have to have a 1 in front of the x squared. Well, you divide everything by a, and you have that. You put your x's on one side, and then you just complete the square, and you end up with a quadratic formula. It's again, it's not complicated, and so that's why that doesn't have a name attached to it. It's just called the quadratic formula. But it is a formula that you are going to need quite often in this course and the next course. It's a formula that you will have to memorize because it is used constantly, and I mean constantly up through it college algebra uses it nonstop. You use it a little bit in calculus just because quadratic equations are very easy to manipulate and mess with and move around. But again, you have to use the quadratic formula. And um, it's pretty easy. It's the epitome of plug and chug. What I mean by that is you just simply plug values in and then I guess you chug, you know, and that's it. So let's go ahead and solve this problem by using the quadratic formula. All right, well, before we begin, what we're going to do is we're going to go ahead and the move the constant. Y'all can't see my mouse. Move the constant over to the left side and have everything equal to 0 because that's what it's asking for here in the quadratic formula. So let's go ahead and do that. Let's move everything to the left side. So we're going to end up with a 2x squared minus 3x and then plus 5, all that is equal to 0. All right, so let's do some. I'm gonna do maybe some color coordination on the first two problems, but it gets very tedious from there. So I'll cease after that. But just follow along. So anyways, here we go. So red is going to be a. So a is equal to, well, it's going to be equal to 2, right? Because that's in the a spot. You know what would actually be better if I did this? And then we'll do this for minus 3. So b is, oh, this is genius. Sometimes I surprise myself. All right, so a, b, and c. So what we have to do is we're just going to plug these into the quadratic formula, and for this particular problem, let's go ahead and just write all this. So x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the all over 2a is in my experience the hardest part for the students to memorize. And by that, I mean when they just put that equal sign there, a lot of students just stop right there. Right? And they just put the radical over the 2a. Right? But it's everything's over 2a. So please don't make that mistake. Anyways, so we've got we're just going to play some fill in the blanks here. So we've got a negative b, so it's going to be a negative and then negative 3, right? Because b is a negative 3. So it's going to be a positive 3 here. plus or minus b squared. Well, b squared, b over here is -3. -3 squared is 9. So we're going to go ahead and fill this in with a 9. Actually, let's go even slower than that. Let's go even slower than that. Just for this problem at least. So we have a -3. Okay, so hopefully you see how this is very tedious for me, just going back and forth with the colors. I don't like that parentheses. There. Oh, not over. All right. I mean, yes, technically it is over, 2 times a, but a does indeed have a value, which is 2. Right? And from here, let's go ahead and snip this and take it to the next page because we're going to have to do the arithmetic following here. There we go. So we've got x. Now let's go ahead and do the math. So a -3, well, that's just going to be a +3, plus or minus the square root of, well, -3 quantity squared, that's going to be 9. And then we have a -4 times, that should be a, oh, yeah, dadgummit. All right, so I knew this was wrong because we did not want to start off with a negative discriminant. And we'll talk about discriminant here in a moment. There we go. All right, so a -4 times a +2 is a -8. -8 times a -5 is a +40. So we're gonna have a +40 in here. Okay, and again, I just did this math right here. So +40, and it's all over 2 times 2, which is 4. Okay. Well, we have 3 plus or minus. Well, we have 9 plus 40, which is 49. The square root of 49 is 7. So we have 3 plus minus 7 all over 4. And then, of course, my solution is going to be 3 plus 7 divided by 4 and 3 minus 7 divided by 4. So what is 3 plus 7 divided by 4? Well, that's 10 divided by 4. So we'll say x is equal to 5 halves, right? That's 10 divided by 4. And x is equal to 3 minus 7 is a -4. -4 divided by 4 is a -1. So these are my solutions to this equation. And real quickly, looking at this problem, how do we know when to use a quadratic formula? Right. Well, how do we know when to use the square root method? Well, how do we know when to factor, right? Because these are the 3 methods that we have seen to solve equations. Well, if it's easily factorable, go ahead and factor it. It'll do you a lot of good to just go ahead and factor it. And if you can't factor it, do the quadratic formula. Now, there are times where you need to complete the square, and it's used quite often, especially in trigonometry. Whenever we, let's see, is it trig? Kind of. I don't know. Whenever you deal with circles a lot, you need to complete the square. But my own personal rule is, if I cannot factor the problem within 3 seconds, if I can't factor it in my head, I go straight to the quadratic formula. And we'll see we'll see what I mean by that here. We'll just do this problem. Okay. So, I mean, obviously, this is a solve the problem using quadratic formula, but just for the sake of, let's just pretend that, well, first of all, let's go ahead and distribute this. So we have a negative x squared, so it's going to be plus 6x, and then minus 11 is equal to 0. Okay, so what I did, I just went ahead and distributed the negative x, and I went ahead and brought the 11 over. Okay, and then let's go ahead also and multiply this entire problem by -1. So I end up with an x squared minus 6x plus 11 is equal to 0. Okay, so I just multiply the entire problem by -1, and that's what I get. right? So if I were to look at this and, never mind the fact that it says that it's a, solve by using the quadratic formula, you're going to have problems where it just says solve, right? That's it. Just solve. Okay. Well, looking at this, I'm going to say, all right, well, I can't really factor this in my head because, I mean, 11 is prime. I can't factor this in my head. And then boom, right there is what tells me I'm going to just use the quadratic formula. And that's it. Okay. So using the quadratic formula, we're going to say x is equal to, it's going to be a negative b, so it's going to be a negative, negative b, so it's going to be a negative, negative 6, plus or minus the square root of b squared, which is going to be a negative 6 squared, minus 4 times a, which is 1, times c, which is 11, all over 2 times a, which is a 1. Right, and then doing this arithmetic, we end up with a negative negative 6, which is 6 plus or minus. Well, negative 6 squared is 36, and this is very unfortunate because it's a 36 minus a 44, because negative 4 times 11 is a negative 44, and well, 36 minus 44 is negative 8, so we're going to end up with the square root of a negative 8, and it's all over 2. And we can fix this up a little bit even further, and we can say 6 plus or minus. Well, we can say that this is the square root of. We can say 4 times a negative 2, right? We can say that. Or no, let's do it this way. Let's just make the 4 negative. So negative 4 times 2, right? Because negative 4 times 2 is indeed negative 8. So we can write this. So negative 4 times 2, well, we know that the square root of negative 4, it isn't a perfect square per se in the real numbers, but it is in the complex numbers. Well, what is the square root of negative 4? What's going to be 2i. So let's go ahead and, we'll just go ahead and go into that stage right now. So 6 plus or minus, and then 2i on the square root of 2 all over 2. And then we can do quite a bit of, well, I won't say canceling. Dude, this ain't going to fit. Let's see. Yeah, okay, we can just do it this way. Well, we know that this 3 and that 2 cancel, so that cancels. And then this 2 and that 2 can't. No, we're going to do this a long way. I feel like that's not really showing anything. Let's do it this way. Okay. So I know that I can factor a 2 out of my numerator, right? So I can factor a 2 out of my numerator, so that leaves me with a 3 plus or minus, plus and minus I on the square root of 2, and that's all over 2. Right? And then from here, I know the 2's cancel like this, and so that means I've got a 3 plus or minus I on the square root of 2. Okay. All right, so hopefully that helped out a lot. Yeah, I'm glad I went ahead and did that on the next page. Example 2. Man, if I recall, this particular section has I think like 11 examples. Yeah. All right, but we're on to example 3. All right, so using the quadratic formula in application. Let's go ahead and we'll go down to here. I like their triangle better. We'll go down to here. All right, so the thought process here is you just make triangles. And here's the thing. In word problems right now, I know that right now as a student you probably hate word problems, which is kind of ironic because every student I ever hear is like, when we're ever going to use this, but then when we actually use it in something that we are ever going to use it, eyes roll. But anyways, turning things into triangles really help because the Pythagorean theorem is so useful in so many word problems, and this is one of them. So a delivery truck travels south from Hartsville, Alabama to Birmingham, Alabama along Interstate 65. The truck then heads east to Atlanta, Georgia along Interstate 20. The distance from Birmingham to Atlanta is 8 miles less than twice the distance from Hartselle to Birmingham. Nah, I probably should have. Maybe I shouldn't have pulled that out. I'm sorry. If the straight line distance from Hartselle to Atlanta is 165 miles, find the distance from Hartselle to Birmingham and from Birmingham to Atlanta. Yeah, I probably should just built this triangle. I'm sorry about that. But anyways, we know that, just reading here, that we are going, a delivery truck is going south from Hartselle to Birmingham, so we're going south, and then they're going to immediately head east and go to Atlanta. Okay, and then later on in the problem, we're told the distance from Hartselle to Atlanta is 165 miles. Well, we're also told that, where are we at? There we go. The distance from Birmingham to Atlanta is 8 miles less than twice the distance from Hartselle to Birmingham. So you would say 8 miles less than twice the distance. So if Hartselle to Birmingham was X amount of miles, then 8 miles less than twice the distance is written as 2x minus 8. Yeah, I really should just built this triangle myself. Hopefully you can follow along. I mean, it's not hard. But that's the triangle. So we want to find the distance from Hartselle to Birmingham and from Birmingham to Alabama. So we need to figure out what this x value is, because if we figure out what x is, we know the distance from Hartselle to Birmingham, and then plugging that x into this equation, 2x minus 8, we can figure out the distance from Birmingham to Atlanta. So in order to begin this, we're going to have to construct the Pythagorean theorem, right? It's a squared plus b squared is equal to c squared. So this is going to get completely out of hand, I know. So a squared plus b squared is equal to c squared. Well, we're going to let this side be a, this side be b, and of course the hypotenuse is always c. So we have x squared plus 2x minus 8 squared, and it's equal to 165 squared. Okay, and this is obviously where it gets pretty sticky. We know that we have x squared here, and then plus, well, this is a squared, so it's 4x squared, a squared plus 2a, or maybe minus 2ab, sorry, minus 2ab, so it's minus 32x. And then plus b squared, which is 64. And that's equal to, I don't know what 165 squared is off the top of my head. It is 27,225. 27225. Ready? Okay, so now I'm going to have to combine like terms and put everything on the left side. So this actually isn't terrible. (5x squared minus 32x). And then we subtract 64 from this, so it's going to be, or we add 60, so it's going to be minus 27,161. There we go. All right, now we can do the quadratic formula, because even if this could factor, again, I give myself 3 seconds. If I cannot factor this in 3 seconds, I am moving on. But we are going to do the quadratic formula instead. So it is, we have x is equal to negative b, so negative b is a negative 32, plus or minus the square root of b squared, so it's a negative 32 squared minus 4 times a times c, so 4 times a, which is 5, times c, which is a negative 27161. I thought my radical was big enough, it wasn't. That's all over 2a. Okay. All right, so let's put this into the calculator and hope I don't make any mistakes. Well, this number is pretty easy, right? A negative 32 is a positive 32, plus or minus the square root of, I wonder if it's easily squared. I don't know. So we've got negative 32 squared minus 4 times 5. Okay. I'm getting a different number than I thought I would. 1 second. Okay. So 5, 4, 4, 2, 4, 4. All over 10. Okay. Whew. So, I'm not done yet because I'm going to figure out what these numbers are, right? I'm gonna take the positive of it, right? Because it's a plus or minus, and then I'm gonna take the negative of it, and we're gonna see what happens here. So 32 plus the square root of 544. Well, I didn't put square root plus the square root of 544,244, and then all that divided by 10 is 76.97. So we'll just write that to 77. And then the minus of it is a negative 70.5, so minus 70.5. Okay, so what did I just do here? Well, I found the value of x, and let's go back to this. And x was the distance between Hartselle, Alabama to Birmingham, Alabama. All right. Well, if uh, we don't talk about distances in negative numbers, right? If somebody says, "Hey, where's the nearest Kroger?" You don't go, "Oh, it's negative 4 miles that way," right? You say it's 4 miles that way. And so what we're going to do is we're going to completely disregard this negative value. Okay, so we're going to stick with the 77. So the distance between Hartselle, Alabama to Birmingham, Alabama is 77 miles. Okay, so let's put it down here. So Hartselle to Birmingham is 77 miles. And then we also want to know Birmingham to Atlanta, I believe, right? Well, Birmingham to Atlanta was 2 times x minus 8. So 2 times 77 minus 8. So that's 154 minus 8 is 146. Okay, so the distance is 146 miles. All right, so I knew that was going to be a doozy, and there it was. But we got through it. And that was just example 3. Holy smokes. All right, so this isn't too bad, though. Alrighty, so here we go. We are asked, or the problem rather, is just simply a model rocket is launched straight upward from the side of a 144-foot cliff. The initial velocity is 112 feet per second. The height of the rocket, h of t, is given by our formula there, where h of t is measured in feet, and t is the time in seconds after launch. Find the time at when the rocket is 208 feet above the ground. So the we're told that h of t is the feet, right? I mean that's what the problem said. It said where are we at? It said the height of the rocket h of t is given by that formula. Okay, well we are told to find the time at which the rocket is 208 feet above the ground. So in this particular function, I have two unknowns. One unknown is h of t, and the other unknown is t. Well, we're asked to find t, so we are obviously given h of t. So my problem is going to turn into 208 is equal to negative 16 t squared plus 112t plus 144. All right, and then let's go ahead and solve this for, let's solve this, well, not solve this for t, but let's go ahead and move everything to one side. We're going to move everything to one side and multiply by negative 1. And let's go and move everything to the left side, because again, I like things on the left side. It's just, it's weird, you know, it's how you've always done things, and that's how it is. And then 1, 4, 60, 66, and 8. Did I do that wrong? 60. No, okay, we're good. Plus 144. It's 56. That's what it is. Okay. Yeah, I knew I messed up somewhere. So we got plus 64. All right, so that's the problem with mental math sometimes. Your mental capacity kind of gets drained. So anyways, so if I lost you there, because especially because there was a long pause, from here, what I'm doing is I went ahead and subtracted 208 from both sides. Okay, and if I subtract 208 from both sides, I get a negative 64. Okay, but I simultaneously put everything on the left side. Um, And I mean, honestly, in one of two ways. I could have simply added everything both sides, or just flipped sides and multiplied by negative 1. But this is my equation, and I want to find h of t. I need to find what happens when I hit the ground, right? And that's also why I chose 0 in this particular case. Because we are hitting the ground. That's ground level. The ground level is at height 0, and so that's how we proceed. And then from here, let's go ahead and use the quadratic. Oh gosh, this is gonna be awful. Actually, 16 goes into all of these, doesn't it? 16 goes into 64, and then it goes into 80, 96. Yeah, it goes into all of them. So I can go ahead and divide this entire problem by 16 and make it so much easier. So we got t squared, and then it goes into it, 16 goes into it 7 times, and 64 4 times. Oh, that's so much easier. Okay, good. So this isn't nearly as bad as I thought it was going to be. But anyways, from here we just do the quadratic formula. So we just say negative b, so negative, and b has always been negative so far, hasn't it? Plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 4. Now, real quickly, before I actually do proceed here, 2 times a. Notice how every single time, b has been negative every single time, but notice how every single time I put the negative from the quadratic equation out front, and then I put in parentheses what the number actually is. I feel like it's good practice for you to do that instead of trying to take shortcuts and try to get done with things quickly. Because if you do that, you're gonna mess up. Um, you just will. Your brain will be fatigued. I mean, a second ago I was saying in my mind, right, 200 minus 144 was 66, and you're gonna mess up. That's my third lecture in a row, and I'm assuming many of you are probably taking a lot more than one class. So you know you're also doing multiple classes, so you're gonna be fatigued. So try to be precise with your negative numbers. They will sneak up on you and they'll get you a lot, right? But anyways, moving on, let's go and put x equals 2 here. Oh, x is equal to, so x is equal to, and let's go ahead and do this calculation here. Let's just write it like this. So negative 7 is a positive 7 plus or minus. So we've got 49 minus 16, which is 33. So I didn't need a radical that big. And 33, all that over 2. So my two solutions will be 7 plus the square root of 33, all divided by 2. So let me put that in here. We have 6.37, 6.37, and then 7 minus the square root, so minus, and it's a 0.63. Okay, so what this is saying is that these two numbers, the rocket, all right, we were asked, find the times at which the rocket is 208 feet above the ground. Okay, well, we put the 208 over here for 208 feet above the ground. We solve for 0. I think I said earlier, maybe it didn't make sense. It's going to reach 208 feet in 0.63 seconds. So right after liftoff is it going to reach 208 feet. And of course we see that here. And then as it flies and it comes back down right over here, 6.37 seconds after liftoff is also going to reach 208 feet. And so this is what that means. And I think that's pretty cool. You know, we get to see, we get to create equations based on, you know, what we're looking at here. Okay. And does the discriminant really take up this many problems? Huh. Oh, there it is. By any means necessary. Okay, yeah, that's what I was talking about. I didn't know it was coming this quick though. Okay, so the discriminant. The discriminant is such an easy concept that we're going to go over it together, and I'm pretty sure you'll be able to come up with these rules on your own. So let's go ahead and mark these out. You know what? Actually, let's mark this out too. Okay. So discriminant is something that you can just use and do pretty quickly to see how many of what type of solution we have. All right. So what does that mean? Well, we've got the radicand with it reads the radicand within the quadratic formula is the expression b squared minus 4ac. This is called the discriminant. The discriminant can be used to determine the number of solutions to a quadratic equation, as well as whether the solutions are rational, irrational, or imaginary numbers. So, the way we do this is, notice that b squared minus 4ac. We have seen that before somewhere, haven't we? Of course we have. It is we'll do it here. It is right here inside the radical, right? B squared minus 4ac. And that part tells us what exactly of how many solutions we're going to have. Now, of course, I did a lot of erasing there, or not erasing, but I did a lot of blocking out here in the red because we can come up with these on our own. So let's just start. So consider the equation ax squared plus bx plus c is equal to 0, where a, b, and c are rational numbers, and a is not equal to 0. The expression b squared minus 4ac is called the discriminant. Furthermore, okay, so let's just decide here. So if b squared minus 4ac is greater than 0, then what do you think is going to happen? Well, if it's greater than 0, that means that inside the radical we have a positive number. Okay, and if we have a positive number inside the radical, what does that mean? That means there's going to be two solutions, right? Because it's a plus or minus the radical in the quadratic formula. That's not the eraser. So we're going to have two solutions. All right, and then furthermore here, you know, if it's a perfect square, then obviously we're going to have a rational number. But if it's not a perfect square, we're going to have irrational numbers. Okay. Of course, we've seen that before. Alrighty, well, if the discriminant, all right, if what is inside the radical is less than 0, well, we've seen this already before. If it's less than 0, then we're going to have imaginary numbers. Let's make that a little bigger, the eraser. Imaginary numbers. And if it's equal to 0, which we haven't actually seen one yet, but if it's equal to 0, then there'll be only one rational solution. And let's see what that means real quick. So if this square root of 33 was just a 0, right? then it would be 7 plus or minus square root of 0, which doesn't really, you don't really have to say that. So it would just simply be 7 over 2. And that's why it would just be one solution. And we didn't actually have one of those problems, but that's okay. So this is used the discriminant, but I'm going to go ahead and just snip this whole thing because this is further plug and chug, and it's even easier than the quadratic formula. So using the discriminant, use the discriminant to determine the type and number of solutions for each equation. Well, all we have to do here is do the b squared minus 4ac. Well, for a, if we did b squared minus 4ac, again, just plugging stuff in, we have a negative number. Well, according to our rules that, a we can come up with and b that are listed here, if it is less than 0, then there's going to be two imaginary solutions. And of course, that's true. And then, same thing can be said for b, c, and, well, not same thing, but same procedure, right? We get the we get the discriminant of b, we get 25. We know that 25 is a perfect square, so there's going to be two rational solutions. 52, when we get the discriminant of c, is not a perfect square, so there's going to be two irrational solutions. And then lastly, we have a value that is equal to 0, for the discriminant is equal to 0. And so since the discriminant is equal to 0, then we know there's only going to be one solution. Okay, and again, that's kind of going back to what I said about if this 33 was a 0. So discriminant's pretty easy. And of course, we're going to do more than just that. Okay, so here we go. Now we're going to step it up and figure out, or not figure out, but use what we've learned to actually, graph equations and figure things out on a deeper level now. Okay, so A, oh, nice and thick there. So A, so given that f of x is equal to x squared minus 3x plus 1, we're asked to A, find the discriminant and use it to determine if there are any x-intercepts. Okay, so the discriminant again is the b squared minus 4ac. So b squared is going to be a negative 3 squared, b squared minus 4 times a, which is 1, times c, which is 1. All right, so we've got 9 minus 4, which is equal to 5. Okay, so since this is a number that is greater than 0 and it is not a perfect square, we're going to end up with two real solutions. Right. Next up, we need to find the x-intercepts. Okay, so in order to find the x-intercepts, and it says if they exist, and we'll see a problem like that here in a moment. In order to find the x-intercepts, well, that's what the quadratic formula is. I notice how every time hopefully every time I put the quadratic formula, I put x equal to, x equal to, x equal to. And of course that down there just means I'm proceeding on. X equal to, x equal to, and of course the quadratic formula, x equal to. So that tells us, well, in order to find the x-intercept, we just need to use the quadratic formula. So let's go ahead and use the quadratic formula here. Actually, let's see. Can I factor this in my head? No, I cannot. Okay, so we're going to have to use the quadratic formula. So in order to use the quadratic formula, we're just going to write this out. So we got b is negative b. So again, man, b has been negative every single time. I guess it's really driving home the point. I don't know. Plus or minus b squared minus 4ac. So we've already done this with the discriminant, but that's okay. Well, that part anyways. All over 2a. And let's be more clear here. I was just talking about how I put x equals to every time. All right, and all over 2a, so 2 times a, which was is also 1. All right, and then if we proceed here, a negative 3 is a positive 3, plus or minus. Well, we know what's inside the radical. We did that with the discriminant. So we got the square root of 5 all over 2. Okay, so my x-intercepts are, let's fix this up. Let's see. I wonder what does the textbook want here. Okay, so it's kind of weird, but it's wanting these actual values. So it's about 2.6 and about 0.4. So we'll go ahead and just write that out. So about 2.6 and about 0.4. Okay, and that's just gotten you just derive that by saying 3 plus or minus the square root of 5 over 2. Well, actually 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. And then C, find the y-intercept. And this is the easiest thing we're going to do in this class. Well, this section. The y-intercept. All right, so if you recall, in order to find the y-intercept, you set x equal to 0. In order to find the x-intercept, you set y equal to 0. In order to find the y-intercept, you set x equal to 0. All right. Well, we kind of did that with the quadratic formula because we are indeed setting y equal to 0. Right? But we just use a quadratic formula because it's nice and convenient. But again, it is pretty much the same as setting it equal to 0. Well, in order to find the y-intercept, we set x equal to 0. Well, this doesn't get any easier than this. All right, this is my function. And if I set x equal to 0, this is 0, this is 0, and so it's just 1. So my y-intercept is just simply going to be equal to 1. Or let's say we'll put 0, 1. And honestly, let's be super consistent here and write the x-intercept like so. All right. So the y-intercept is super easy. The x-intercept is just simply the quadratic formula, and of course, getting the discriminant is getting the discriminant. All right. So more problems here. Looking at here, the y-intercept is 2, right? Doesn't get any easier than that. So you just basically look at the constant. So find the discriminant and use it to determine if there are any x-intercepts. Okay, so in order to find the discriminant, we need to just, again, it's b squared minus 4ac. Well, b squared is a 1, so 1 squared minus 4 times a, which is 1, times c, which is 2. Oh, this is not going to be good, right? So we end up with a negative number, right? So 1 minus a is a negative 7. All right. So since it's a negative number, this tells me that there are going to be no x-intercepts because my solutions are going to be imaginary solutions. So that leads into B. This tells me that there's going to be no intercepts. No intercepts. And then C, the y-intercept is just going to be 2. 0, 2. And again, it's just so easy, right? X goes 0, x is 0, and that's it, just 2. Right. And so what does a graph with no x-intercepts look like? Well, not a brain buster, pretty easy, especially if you just thought about it. But I will admit, after 43 minutes, you're probably not thinking about x-intercepts too much. Okay. So the next few are solve quadratic equations by any means necessary. So let's see what we got here. We just have to solve it. It doesn't matter how we solve it. We could use factoring, we could use square root method, or we could use a quadratic formula. But like I said, for me, if I can't solve it with by factoring really quickly, then I'm not even going to play the game. Then I'm just going to go straight to the quadratic formula. So let's go ahead and expand the binomial here on the left. So x plus 3 quantity squared is just going to be x squared plus 2ab, which is going to be 6x plus 9. And then we say plus x squared minus 9x. And then let's go ahead and subtract the 8 from both sides. So minus 8 is equal to 0. Whew. All right, so now let's go ahead and combine like terms here. So we're going to end up with a so let's combine like terms. We're going to have an x squared, 2x squared actually. So let's do that. So 2x squared. That takes care of this x squared and this x squared. looks like a minus 3x, so minus 3x, right? Takes care of that and that. It looks like a plus 1, that's equal to 0. Of course, that takes care of this and this. All right, and luckily I can factor this in my head really quickly. It's just going to be 2x minus 1 and x also minus 1 is equal to 0. And then using our zero product rule, we see that we can have x is equal to 1/2 and x is equal to 1. Right? So that's why sometimes factoring is just so much easier. If you can factor, you do it. If you can't, then do the quadratic formula. And I have a sneaking suspicion I will not be factoring this one. Nope. All right, so this is interesting. I believe they go straight to the. Oh, okay. Alrighty, so here's where maybe my method is fallible, um, because if I'm doing this, I'm in a hurry to get things done, and I don't feel like thinking about it. Now I know that is very counterintuitive to the way I do teach sometimes, but I think it's good to delve into the mind of a mathematics instructor, right? So I'm supposed to solve this using any method. So let's go ahead and the way I would do this is I would say, okay, so x squared, and then I would say I'm adding 2x to both sides, so plus 2x and then plus 5 is equal to 0. Okay. Unfortunately, I cannot factor this in my head, okay, because you just can't factor it. The textbook is actually going to go about completing the square. Now, if you want to, you're more than welcome to. Okay, but like I said, my rule is if I can't factor it in 3 seconds, I go straight to the quadratic formula. So here we go, quadratic formula. X is equal to negative b, so finally we end up with a positive b to negate, right? So negative b plus or minus square root of b squared, so 2 squared minus 4 times a times b times b, which is 5, all over 2 times 1. Okay, so let's fix this up. So we have a negative 2 on the square root of 2 squared is 4, 4 minus 20, so a negative 16, all over 2. Okay, well, negative 16 can be 4, 20, hang on, that's 4 times 8 times c. Okay, so I've got a negative 2 on the square root of negative 16. Well, negative 16 can turn into I on the square root of 16 or 4I. So this turns into, oh, I forgot my plus or minus sign there, sorry. So negative 2 plus or minus the square root of negative 16. Okay, and then we're going to continue it down here. So we've got a negative 2 plus or minus 4I all over 2. We can factor out a 2 in my numerator, so let's go ahead and do that just to kind of show what we're doing here. So we've got a 1 plus or minus 2I over 2. Let's see, that's a negative 1. Sorry, because I factored out a positive 2. And I can't do anything but dots. There we go. All right, well, I know the 2 is obviously going to cancel, so I end up with a negative 1 plus or minus 2I. And that is my solution set. Now, let's go back and look at what the textbook did. Again, the textbook, what they did here was they completed the square. There's nothing wrong with it, but again, it's just not what I do first things first. They completed the square, then they did the square root method, and we still got the same solution. All right, so it's up to you. It's your prerogative. For me, man, I would just go ahead and do the quadratic formula. Alrighty, so 1/4 x squared minus 1/2 plus 1/3. So in order to get rid of these fractions, I need to multiply this entire problem by the least common, well, I need to figure out what the least common denominator is, and then multiply the entire problem by that least common denominator, so I can get whole numbers. And looking at this, I see that I have a 4, a 2, and a 3 as a denominator. Okay, so what I need to do is I need to multiply this entire problem by the smallest number that those three numbers will go into. All right, so let's just write that out and see what it looks like real fast. Okay, so the smallest number all three of these will go into looks like it's going to be 12. So I'm going to multiply this entire problem by 12. And we'll just put 12 over here. Okay, and we just distribute, and then the equal sign, it doesn't really matter, it's in the middle, and then distribute, which 12 times 0 is still going to be 0. So if we multiply this entire problem by 12, we end up with a 3x squared minus, looks like what's a 6x, and then plus 4 is equal to 0. Okay, so that's pretty easy. Now that we got this, all I have to do now is, well, can I factor this in my head? No, I mean, I might could, but I don't feel like dealing with it. So I'm going straight to the quadratic formula. Like, that's exactly how it is. That's how my brain works, and that should be how yours works, right? Maybe, I don't know. I mean, you could sit there and factor it or square root method if you want to, but I'm telling you this is better. So we've got a x is equal to a negative b. Oh, shocker. It's a negative number. So negative b plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is 4, all over 2 times a, which is 3. So what is this equal to? So we got negative 6, which is positive 6, plus or minus the square root of 36 minus, looks like 16 times 3 is 48, so negative 12 here, all over 2 times 3, which is 6. Okay, so let's go ahead and snip this and put this on the next page, because we're going to do some extra stuff to it here. Okay, so I know that the negative 12 can be changed into a 4 times a 3, right? So I can say 6 plus or minus the square root of, we'll just say negative 4 times 3 all over 6. And well, I know that the square root of negative 4 is going to be 2i, so I can say 6 plus or minus 2i on the square root of 3 all over 6. And the same as before, I'm going to go ahead and factor a 2 out of my numerator. So I'm going to factor a 2 out of my numerator, and I'm going to say 2, so I got 3 plus or minus 1i, or just simply I, on the square root of 3 all over 6. And I can do my canceling like so. And then I end up with a 3 plus or minus I on the square root of 3 all over 3. Whew, lots of 3's. I don't, well, I could actually fix that up a little bit. I don't know how the textbook wants it, but we can kind of fix that up, because we know that this can also turn into, and let me get another page for this, because I want to make this nice and neat. I know that this can turn into, this is the same thing as saying 3 over 3 plus or minus the square root of 3 over 3i. Okay, so basically I just put the I from the front to the back of a fraction, no big deal. You can keep it in front if you want to, and again, I don't know how the textbook wants it, but we have the 3 in this denominator here. We've seen stuff like that before, right? If we had 7 plus x over 9, we know that's the same thing as saying 7 over 9 plus x over 9, and that's all I did there. And again, I'm not necessarily sure how the textbook wants it, but those are the two ways, and let's just see what the textbook has here. Yeah, we do indeed fix it up and reduce it. So yeah, I'm glad I did go over that. And then the last one, and this winds down probably I think the longest lecture we've had in this course. Example 11 here. We've got, it reads, solve the equation by using any method. Okay, so this doesn't seem too bad, right? I don't know what the trick is here, but let's just proceed. It looks like I can just take the square root of both sides. So before we begin, let's go ahead and add 11 to both sides. So we're going to have a 9p squared, and that's equal to 11. Let's divide both sides by 9. So we're going to have a p squared is equal to 11 over 9. And then I guess, I don't know. Then we're going to take the square root of both sides there. So it's going to be p is equal to plus or minus the square root of 11 over 9, which we know is going to be plus or minus the square root of 11 over the square root of 9, which is 3. I don't really know what the trick was there. Why was this the last example? You would think it would be harder, but that was, I mean, I obviously knew it was short because I saw that when I snipped. I don't know. Sometimes I just don't get it. Anyways, that concludes today's lecture.